part of our project, we're going to do bivariate analysis. So, which means what we'll do is that we're going to identify the linear relationship between two variables. So let's start with the CLV, or customer lifetime value and income, and also the CLV versus the monthly premium auto. So we have this to do that. And basically what we do here is we have two scatter plots for these codes. First, we have income versus the customer lifetime value. Then we have the monthly premium auto versus the customer lifetime value. So let's execute this one and let's see the relationship. So you have in there as to whether or not this and this one have linear relationship. We have to always take note of the positive and the negative relationship, or positive and negative linear relationship. So this one, CLV versus income, the relationship is not that more pronounced. It's not really positive or negative. It's just somewhere in between. The monthly premium auto, we could see that it's actually a positive linear relationship. So it's good. Now we have the CLV versus months since last claim and CLV versus months since policy inception. So let's see if there is positive or negative relationship. Right. Now you have in there, for the first one, this one is not really good. And also with respect to this, although in this case CLV versus months since policy inception, it could be somewhat positive, but not that higher in comparison to the CLV versus monthly premium auto. Let's go to CLV versus total claim amount and CLV versus number of open complaint. Let's see. Let's execute this one. You have in there. So for this one, the first one, CLV versus total claim amount, we could see that the relationship is linear, positive linear relationship. And for this one, CLV versus number of open complaints, it's actually in negative relationship, which means that as one increases, the other decreases. Let's have the CLV versus number of policies. Let's execute this one first. Now we have in here. It's actually somewhere in between, not really very negative, not negative, not a high positive. And why do we have to do this one? That is always the question. This is actually very important for us to be able to identify which features we're going to use for our prediction. So there are some challenges that we need to avoid. For example, we have multicollinearity, and it's something that we have to avoid so that our prediction would be more powerful. We have here, if we would want to see all the linear relationship, then we may as well have to use the SNS.pairPlot function. So let's execute this one so that we would be able to see all the pair plot linear relationship of all the features in our data set. So let's execute this. It may take a while. Let's just wait. Okay, so we have now the results. So it's here, right? So this, so as you could see, there are linear relationships. All right. Now, this time, what we'll do is that we're going to identify which months we have the highest transactions. First, what we will do here is we create another feature, which is transaction date. So let's execute this. And then what we do here is also we create another feature, which is months. Let's execute this. And let's see what we have in our new data set, which have an additional two features. Let's execute this. And so we have, for the feature months, we have one here represents January and two represents February, which means we have higher transactions in January in comparison to February. So anyway, let's first see what we have in our dataset month. Anyway, let's first see what we have in our data set, having all of the variables that we have engineered. So let's have df.head. Then let's see what we have in there. Right. So now, as you could see, we have here the transaction date and we have the month here. This is for the month of February. Of course, you could see here 2011-02-24. So it's the month of February. This is January. This is Feb, and so on and so forth. Now, it's always better to see these figures using the bar plot, count plot. So let's execute this. Oh, there you are. So it's more visually appealing because we have our plot. So we have for the month of January 4359, and for February we have 3740. Now, next what we will do is that we're going to identify the correlation between and among variables. So let's first have a new table or data frame, which is core math. And as you remember before, we do have created a data frame which is dfnum, which is only limited to the numerical features in our data set. So let's execute this. So we have these values in our correlational or correlation math or map. So we have customer lifetime value. Of course, there is one because it is the correlation with itself. And so as you could see, we do have a lot here, and it's not actually very friendly to read each one of them. So what we will do here is that we're going to do a heat map so that we could see how it goes. So let's see. Let's execute this one. Right now, we have here more pronounced and more friendly to our eyes. So let's see which ones have higher correlation. So we have the customer lifetime value, and this is the monthly premium auto. It has a correlation value of 0.54. This is higher. And also with total claim amount, it is 0.35, and the rest are negative. Then we have the income. Then let's see which one has the highest correlation value. So income and number of open complaints. Let's have this one. This is a monthly premium auto. So this is negative 0.37. Okay. And this one, it is total claim amount. Okay. Of course, that's very understandable because when the claim is higher, then the income of the company would be lower, and vice versa. Okay, what about the monthly premium auto? Of course, it's with the customer lifetime value, and we have the total claim amount. Of course, that's also understandable. So when you have a higher premium auto, then the claim amount would also be higher. Be very understandable. Others are negative as well, but let's have a very interesting negative correlation, which is 0.31. And then we have 0.037 income, the monthly premium income. And then we have the number of open complaints. So they have higher negative correlation. Okay, so now what we will do here is that we're going to identify the ones that have higher correlation values with respect to customer lifetime value. So let's execute this. Now we have the monthly premium auto, which is the highest one among all these other features. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.